Historically, launching a web application required manual XML configuration and the setup of external servers. Today, that entire process is condensed into a single click that initiates a fully functional server. This speed is driven by the @SpringBoot application annotation. It is a combination of 3 distinct instructions: one to mark the class as a configuration source, one to trigger a component scan, and one to enable automatic setup logic. When the code calls SpringApplication.run, it starts the lifecycle, a sequence that executes in the milliseconds before the application is ready to accept traffic. To understand how the framework builds itself, we need to slow down time and observe the exact chronological steps occurring during that startup window. Seeing this sequence reveals the internal logic that dictates how the framework manages your code and resources. The process begins with environment preparation. Spring Boot gathers properties from your files, ls environment variables, and command line arguments, merging them into a single unified environment object. Next, the system creates the application context. This serves as the application's internal memory space or container, defining the boundaries where every object will eventually live. With the container ready, Spring Boot begins component scanning. It searches through your project folders, starting from the package where your main class sits and moving downward through the directory tree. It is looking for classes tagged with stereotypes like component, service, or controller. These discovered objects are called beans. They are standard Java objects, but instead of you creating them manually with the new keyword, their creation and lifecycle are now managed by the framework inside the container. At this point, the application has established its environment and gathered its raw materials, but the individual objects are still isolated from one another. This is where the framework implements inversion of control. Rather than your code controlling the flow and creating dependencies, you hand that responsibility to the framework. In step 4, auto-configuration kicks in. By checking your project's jar files, Spring Boot makes architectural assumptions. If it sees the web starter on your class path, it automatically configures a web environment and a dispatcher servlet. If you define your own custom database connection, the framework detects it and gracefully backs off, prioritizing your specific setup over its default settings. Step 5 uses dependency injection to finish the assembly. This is the specific pattern that turns the theoretical inversion of control into a functioning system. Spring instantiates the beans it found during the scan and wires them together. If a controller requires a service to function, Spring injects that service automatically during the controller's creation. Because the framework handles these connections externally, you can swap one component for another without modifying the code that uses them. This decoupling creates a modular architecture that is easier to test, as you can inject mock versions of dependencies during a test run. In step 6, if the application is web-based, Spring Boot spins up the embedded web server, binding it to a port to listen for traffic. Finally, step 7 executes startup runners, marking the moment the application is officially ready for use. This entire startup sequence is a choreographed execution of conditional logic and automated dependency injection. By managing the assembly of the infrastructure, the framework allows developers to focus their efforts on writing the business logic specific to their application. Understanding these hidden mechanics is a key step in mastering software architecture. Subscribe for more deep dives into how modern engineering tools function under the hood.